The allure of electric avenues, electric vehicles, with their sleek designs and silent engines, have emerged as symbols of progress. They promise a cleaner, greener future, a departure from the smog-filled streets of our fossil fuel dependence. Advertisements portray them as the solution to climate change, a guilt-free way to navigate our world. The allure is undeniable, a chance to embrace technology while reducing our environmental footprint. This narrative, however, requires a closer look. While electric vehicles offer undeniable advantages, their environmental impact is far more complex than marketing campaigns often suggest. To truly understand the sustainability of EVs, we must delve beyond the shiny veneer and examine the intricate web of their production, use, and disposal. Only then can we make informed decisions about their role in a truly sustainable future.
Electric vehicle advertisements often paint an idyllic picture. They showcase pristine landscapes, untouched by pollution, and emphasize the zero-emission nature of their vehicles. The message is clear: choose electric, choose the planet. These claims, while not entirely unfounded, often lack crucial context. They focus on the tailpipe emissions of EVs, which are indeed zero, but neglect to mention the environmental impact of producing the vehicles themselves. The mining of rare earth minerals for batteries, the energy-intensive manufacturing process, and the eventual disposal of these batteries all contribute to the environmental footprint of electric vehicles. While EVs undoubtedly offer a cleaner alternative to traditional gasoline-powered cars, their green credentials are not as straightforward as advertisements might lead us to believe.
At the heart of every electric vehicle lies its battery, a technological marvel that also presents a significant environmental challenge. These batteries are the key to the green revolution in transportation, but they come with their own set of issues. The production of these batteries requires the extraction of vast quantities of lithium, cobalt, and other rare earth minerals. This extraction process is not only resource-intensive, but also has far-reaching environmental consequences. Mining these minerals often comes at a high cost to the environment, leading to deforestation, habitat destruction, and water pollution. The landscapes of mining regions are often scarred, and local ecosystems can be severely disrupted. The processing of these minerals is also energy-intensive, often relying on fossil fuels and generating significant greenhouse gas emissions. This energy consumption adds to the carbon footprint of electric vehicles, counteracting some of their environmental benefits. Furthermore, the disposal of EV batteries at the end of their life cycle presents another hurdle. Proper disposal methods are crucial to prevent environmental contamination. If not handled properly, these batteries can leach toxic chemicals into the environment, contaminating soil and water sources. This poses a risk to both human health and wildlife. While battery technology is constantly evolving and recycling efforts are improving, the environmental impact of battery production and disposal remains a significant concern in the life cycle of electric vehicles. Addressing these issues is essential for the sustainable future of electric mobility.
One of the most pervasive myths surrounding electric vehicles is that they run solely on clean, renewable energy. This misconception often leads people to believe that driving an EV is always a greener choice, regardless of the circumstances. While it's true that EVs produce zero tailpipe emissions, the source of electricity used to charge them plays a crucial role in their overall environmental impact. The cleaner the electricity, the greener the vehicle. In many parts of the world, electricity generation still relies heavily on fossil fuels, such as coal and natural gas. This reliance means that the environmental benefits of EVs can be compromised. Charging an EV with electricity generated from these sources significantly diminishes its environmental benefits. The carbon footprint of the electricity source must be considered. While the transition to renewable energy sources is underway, it is not happening at a pace that can fully support the widespread adoption of electric vehicles without increasing demand on existing power grids. This increased demand can strain the grid and lead to higher emissions if not managed properly. To truly achieve a green transportation system, we need to accelerate the shift towards renewable energy sources and ensure that the electricity used to power EVs is genuinely clean. Only then can we maximize the environmental benefits of electric vehicles and move towards a sustainable future.
Section 5, Lifecycle Analysis, EVs versus traditional cars. To fully grasp the environmental impact of electric vehicles, we must look beyond individual aspects like battery production or energy sources and consider the entire life cycle of the vehicle from start to finish. This includes everything from raw material extraction and manufacturing to transportation, use, and eventual disposal. Each stage has its own set of environmental challenges and benefits. Lifecycle assessments consistently show that while EVs have a higher environmental impact during the production phase due to battery manufacturing, they significantly outperform traditional gasoline-powered cars over their entire lifespan. This is a crucial point to understand. This is primarily because EVs produce zero tailpipe emissions and are more energy efficient, requiring less energy to travel the same distance as a gasoline car. The efficiency gains are substantial. However, the magnitude of these benefits depends heavily on factors like the electricity mix used for charging and the driving conditions. The cleaner the electricity, the greater the benefits. In regions with a cleaner electricity grid and favorable driving conditions, the environmental advantages of EVs are more pronounced. These regions see the most significant reductions in greenhouse gas emissions and other pollutants.
Section 6. Consumer Awareness. Navigating the Green Maze. As electric vehicles become increasingly mainstream, it's crucial for consumers to be aware of the nuances surrounding their environmental impact. Marketing campaigns often present a simplified, overly optimistic view, while the reality is far more complex. Consumers need access to transparent and accurate information about the environmental footprint of EVs, including battery production, energy sources, and life cycle assessments. Armed with this knowledge, consumers can make informed decisions about whether an EV aligns with their environmental values and driving needs. Furthermore, consumers should be aware of the importance of responsible EV ownership, such as charging their vehicles during off-peak hours to minimize strain on the electricity grid, and opting for renewable energy sources whenever possible.
Section 7. The Regulatory Landscape, Incentives and Oversight. Governments play a crucial role in accelerating the adoption of electric vehicles and ensuring their environmental benefits are realized. Incentives such as tax breaks, subsidies, and rebates can make EVs more affordable for consumers, encouraging the transition away from gasoline-powered cars. However, it's equally important to implement regulations that address the environmental concerns associated with EVs. This includes setting stringent standards for battery production and recycling, promoting the use of renewable energy sources for charging, and investing in infrastructure to support the growing EV market. By creating a supportive yet responsible regulatory environment, governments can foster the growth of a truly sustainable electric vehicle industry.
Section 8, Beyond the Tailpipe, a broader environmental perspective. While the focus on electric vehicles is understandable given their potential to reduce transportation emissions, it's essential to remember that they are just one piece of the puzzle in addressing the broader environmental crisis. Focusing solely on tailpipe emissions risks overlooking the environmental impact of other aspects of our transportation system, such as road construction, traffic congestion, and the production and disposal of vehicles themselves. A truly sustainable transportation system requires a holistic approach that encompasses not only the adoption of cleaner vehicles, but also a shift towards more sustainable modes of transportation, such as public transit, cycling, and walking. Section 9, The Promise and the Pragmatism, a balanced view. Electric vehicles hold immense promise as a key component of a more sustainable future. Their potential to reduce greenhouse gas emissions, improve air quality, and lessen our dependence on fossil fuels is undeniable. However, it's crucial to approach the transition to electric vehicles with a healthy dose of pragmatism. The environmental benefits of EVs are not automatic or guaranteed. They depend heavily on factors like battery technology, energy sources, and consumer behavior. By acknowledging both the potential and the limitations of electric vehicles, we can make informed decisions that drive us towards a truly sustainable transportation system. Section 10, Driving towards a sustainable future. The journey towards a sustainable future requires a multifaceted approach, and electric vehicles undoubtedly have a significant role to play. By embracing transparency, promoting responsible consumer choices, and implementing supportive yet stringent regulations, we can harness the potential of EVs while mitigating their environmental impact. Ultimately, the goal is not just to replace one type of car with another, but to create a transportation system that is truly sustainable, equitable, and accessible to all. Let us navigate this path with open eyes, informed minds, and a shared commitment to preserving our planet for generations to come.